Hey there, welcome back to Math Defined. I'm Mrs. C, and today we're exploring probability. Have you ever wondered what the chances are of getting exactly what you want when you roll a die, flip a coin, or pick a candy from a jar? Understanding probability helps you figure out just that. Stick around because by the end of this lesson, you'll be able to identify outcomes, describe how likely events are to happen, and even make predictions using probability. An experiment is an activity or action where the results are observed, like spinning a spinner. Imagine you're spinning this spinner. All the possible results of an experiment like this are called outcomes. How many possible outcomes are there on this spinner? We can count the number of sections the spinner could land on. There are 6 sections, so there are 6 possible outcomes. An event is a specific outcome or group of outcomes you're looking at. Favorable outcomes are what you want to happen. What are the favorable outcomes of spinning an even number? We can make a table. We'll look at the number of outcomes for an even number, our favorable outcome, and then for a not even number. Looking at the spinner, we see 2 sections that have even numbers, 2 and 4. The other 4 sections have the numbers 1 and 3, which are not even. So there are 2 favorable outcomes, landing on a 2 or a 4. Let's experiment with a regular 6-sided die. How many possible outcomes are there when rolling a 6-sided die? We could roll either a 1, 2, 3, 4, 5, or 6, so there are 6 possible outcomes. What are the favorable outcomes of rolling an odd number? We'll organize the possible outcomes for this event by completing another table. The odd numbers on the die are 1, 3, and 5. And the even numbers, or the not odd numbers, are 2, 4, and 6. So there are 3 favorable outcomes for rolling an odd number. But how many ways can rolling a number less than 2 occur? First, let's see how many numbers on the die are less than 2. Be careful, the only number less than 2 is 1. 2 is not less than 2. The numbers not less than 2 on the die are 2, 3, 4, 5, and 6. So there is only 1 favorable outcome for rolling a number less than 2. Now that we've looked at how to list outcomes and identify favorable ones, let's talk about how likely those outcomes are. Probability is the likelihood that something will or will not happen. It's a number between 0 and 1, usually expressed as a percent, that tells us how likely an event is to happen. Let's use this progress bar to give us a visual way to think about probability, from completely impossible to absolutely certain. Let's go through what each part means. If the probability is 0 or 0%, that means it's impossible, like rolling a 7 on a regular 6-sided die. It just can't happen. A probability of 1/4 or 25% means the event is unlikely. It could happen, but don't count on it, like guessing a friend's favorite color on the first try when there are 4 choices. 1/2 or 50% is right in the middle. That means it's equally likely to happen or not to happen. Like flipping a coin, heads or tails, same chance for both. 3/4 or 75% means it's likely to happen. Imagine pulling a red marble from a bag with 3 red marbles and 1 blue. You'll probably get a red one. And finally, if something has a probability of 1 or 100%, it's certain, like the sun rising tomorrow morning. You can count on it. Imagine that the weather forecast for tomorrow says 80% chance of rain in the morning, then 50% chance of thunderstorms in the late afternoon, and 15% chance of hail overnight. Sounds like one wild weather day. Describe the likelihood of rain tomorrow morning. The weather forecast gives it an 80% probability that it will. 80% falls just past 75%, so rain is likely. The probability for thunderstorms tomorrow in the late afternoon is 50%. 50% is exactly at 1/2, meaning it's equally likely to happen or not happen. And the probability of hail tomorrow overnight is 15%. 15% is less than 25%, so hail is unlikely. So it looks like out of all the possible weather events for tomorrow, rain is the most likely. Let's look at a snowboarding event next. This snowboarder practices a jump, and the probability that they land the jump successfully is 3/20. Describe the likelihood of landing the jump using the progress bar. The probability of landing this jump is given to you as a fraction this time, so we'll need to convert it into a percent. We'll divide 3 by 20 to get 0.15, and then move the decimal point 2 places to the right to get 15%. Placing this 15% onto the progress bar, we see that it is less than 25%, so the probability of landing the jump successfully is unlikely. So far, we've been looking at the probability of events before they happen. But what if we collect data from real attempts? That's where relative frequency comes in. Relative frequency is how often something happens compared to how many times you try. Imagine you're keeping track of a basketball player practicing their throws. They take 25 shots and make 19 of them. What is the likelihood that they make their next shot? First, we'll write a ratio comparing the shots they made into the basket to the total number of tries, 19 out of 25. Then we'll need to convert this into a percent by dividing 19 by 25 to get 0.76 or 76%. Placing it on the progress bar, we see that it is just past 75%. So the basketball player is likely to make their next shot. Now let's take what we've learned so far and apply it to another real-life situation where we want to find the probability of something happening. Suppose you have a playlist with 5 pop songs, 3 rock songs, and 2 country songs. What's the probability that you'll randomly play a rock song next? Let's use a table. We're looking for rock songs, and we can see that 3 have been played so far. There have also been 5 pop songs and 2 country songs played for a total of 7 not rock songs. So out of a total of 10 songs played, 3 were rock songs. Converting this ratio into a percent gives us 30%. And then placing this 30% on the progress bar, we see that it's just past 25%. So it's unlikely that the next randomly played song will be a rock song. Let's wrap this up at a carnival where we'll use data and the percent equation to make a prediction. There is a rubber duck pond where you randomly choose a rubber duck and then replace it. The tally table shows the results of draws so far for wins, losses, and free turns. Let's add up the tally marks to see how many draws have occurred so far. 6 plus 15 plus 4 is 25. You want to know how many ducks out of 150 draws you can expect to not be a losing duck. First, we'll find the favorable outcomes, not a losing duck. Wins and free turns are not losing, so we'll add these together to get a total of 10. And the total number of outcomes so far is 25. To find the relative frequency for this event, we compare the favorable outcomes to the total outcomes, so our ratio is 10 over 25. Then we'll convert this ratio into a percent, 40%. We'll need to use the percent equation to make the prediction of how many ducks we can expect to not be a losing duck out of 150 draws. The percent equation is A, or the part, which in this problem is the number of not losing ducks, equals the percent, which is the relative frequency of 40% written as a decimal, times the whole 150 draws. Now we'll multiply these two values to get A equals 60. So out of 150 draws, you can expect about 60 ducks to not be a losing duck based on the relative frequency from the data collected. Based on this probability, would you feel lucky enough to pick a winning duck? Awesome job today! If you found this video helpful, give it a thumbs up, hit subscribe, and if you watch this video all the way to the end, drop a die in the comments so I know you're part of our Math Defined crew. Thanks for watching, and until next time, keep math awesome.